Data types can be classified into two: built-in data types and user-defined data types. Built-in data types include integer, characters, floating points, double, and Boolean. And user-defined include structures, union, and enum. Our discussion will be on built-in data types. So, let's get back to the code blocks to see how things work. First of all, we will start from integer data types. The keyword for integer data type is int. I'm going to declare a variable that can store integer values. That's what this integer data type is all about. Let me say x equal to any integer value can be passed. I'm going to give 12. Okay, fine. What I just did is that I declare a variable x, a variable of the name x that is of a data type integer. Only integer values can be stored in x because it is declared as an integer data type. This is what it means. Things are self-explanatory, like integer data type can only store integer values. Let me try to print it. You know how to print things in C++ by now. Use the cout. Cout x. We will run it. Things are compiling. 0 errors, 0 warnings is fine. Now let's print it. Okay, 12. There you go. So when you try to print it, print x, the value of x is being printed. It is not giving us an error because 12 is an integer and x is supposed to store integer values. So that's how you store integer values into a variable, integer data type. But integer data types can be modified. The range, the size, everything can be modified. That's when modifiers come into place. Now let's discuss about modifiers a bit. Datatype modifiers can be of two different types. They can be signed or unsigned, and also they can be of long and short. Now what does this mean in detail? Let's see. By default, an integer value can store minus 32,768 to 32,767. But what if you want to increase the range? That's when long or short modifiers comes into play. If you write short int, that means by default integer that can store minus 32,768 to 32,767. But if you write long keyword before an integer, that means long int, the range just increases. The value is displayed on the screen, you can try to read it. The point is, the range just shoots up to a very high value. Now, let's move on to the next type of modifiers. We know that integer can have a negative value to positive value. That's the range of an integer data type. But what if you don't need the negative part? That's when signed or unsigned modifiers comes into play. Signed integer means by default an integer that can store negative to positive value. But if you use unsigned integer, you can store values from 0 to 65,535. That means 0 to a positive value. And also the range doubles. The concept might be clear to you. And also you can combine these two data types together. That means you can have signed short int, you can have unsigned long int, you can have signed long int, etc. etc. Also, I have included a table describing data types, modifiers, their memory and corresponding range of values that it can store. It is better that you have a table with you right like this. You can download it from the Google or from my Telegram channel, or also you can screenshot this table. But it's better you have a clear understanding about modifiers and their range. So let's get back to code blocks to discuss more about data types. In this tutorial, I am going to teach you about two more data types, that is float and character. On the screen you can see a data type x of integer which has a value 12, and we have seen what happens Now let's say that you want to store a value like 12.5 with a decimal value, and you're using integer data type to do it. It won't show you an error, but something interesting will happen. Well, 12 is printed to the screen. But what you gave the compiler was that you wanted to store or you wanted to print 12.5, but the compiler decided to print 12 as the value of x. What happened here? Okay, let's see. The integer is supposed to store only integer values, so it completely neglects and rejects all the decimal points that comes after it. That's why the x only printed the corresponding integer 12. So what if you wanted to print 12.5 or any decimal values? That's when you use float. Let's say float y. Float y equal to, I'm giving a value 25.5 and I'm trying to print y. Let's see what happens. 12.5. Now this is how you print values with decimal points to the screen. And this is how you use decimal values with decimal points. So this is where you use float. Now you might have been clear about how and where to use integer data types and floating points, float data types. Okay, let's correct this to 12. An integer can only store integer values and it will neglect the decimal points, and a float is used to store values with the decimal points. And I strongly recommend you go through the table that I given you before and you download it from the net or from wherever you want to and refer to it, because float has a much greater range of values than that of integer, and it is important that you understand it. But when it comes to coding, simple coding, you are going to use float only to store values with decimal points, and that's it. But it's better that you know the range of values. Now I'm going to show you another type of data type called character. CHAR is the keyword. Character, say, is it equal to. Okay, now what this means, the character data type means that it can have values from 0 to 255. That means it can store 255 characters. Listen to me carefully, it can store 255 characters, not values, characters. Because it doesn't mean that you can store 0 to 255 numbers from 0 to 255 like 0, or you can have any values between 255. It's not like that. It doesn't mean to say like that. It means that it can have 255 characters from A to Z, from 0 to 9, and you can also store values like hash, plus, minus, star, etc. I'll show you an example. But remember to put single quotes. Anything that you want it to be stored in character data type should be in single quotes. In single quotes, I'm going to write hash, symbol hash, and I'm trying to print the hash to the screen. And by far, you know that there is no way to print hash using integer or float, as hash is not a number. Hash is a character. So the only way to print hash to the screen is using character data type is it. And you must tell the compiler that it is a character by placing it inside a single quotes. Now let's see what happens when you run the code. Hash, symbol hash is printed to the screen. Now that's how you use integer, float and characters. And I strongly believe that by now you might have understood the basics about data types and what values can be stored into different data types like integer, float and character. And there are two more important data types which I am not going to explain elaborately in this tutorial, that is double and Boolean. What is double and Boolean? I'll just tell you in a simple words. Double can store very big values including decimals, integers, negative numbers, it can store a huge amount of values. That's when the cases where you use double in your codings will be very, very rare, unless you are doing a very big project or developing a game or something like that. And when it comes to bool, it can only have two values. Let's say Boolean data type a variable a with Boolean data type can only have two values. Either it can be true or either it can be false. This is the only values that can be associated with a Boolean data type. You will get to use Boolean when it comes to using while loop, for loops and condition statements, all those kinds of things. When it comes to that stage, I will explain to you elaborately where and how you use Boolean. For now, you just understand that a Boolean value can only have two values, true or false. Now these are all the data types, the basic data types in C++ language, and hope it is clear to you. And please remember to get that table that I showed you before, download it from my Telegram channel or get it from the Google and refer to it when it comes to memory, range and modifiers. If you like the content, please subscribe the channel and press the bell icon for more videos like this.